In this tutorial, we will see how to perform a multiple regression forecast with the intercept, slopes, and correlation coefficient given to you. Please note that this is an advanced topic and many instructors will choose to skip it. The calculations for multiple regression are too complex to perform by hand and will not be demonstrated here. If your instructor has a multiple regression forecast problem on the exam, then either he is giving you the parameters or you have access to software. For this tutorial, we will be demonstrating the calculations using Excel. This uses the Data Analysis Tool Pack. This add-in was demonstrated with simple regression forecasting in case you need to review it. Multiple regression is like simple regression, only with more than one variable. A multiple regression forecast may or may not include the period. In simple regression, the forecast was the intercept plus the slope times the period number. Multiple regression works the same way except that each variable has its own slope. So the forecast for any period is the intercept plus the first slope times the value of the first variable plus the second slope times the value of the second variable, and so on if there are more than two variables. For this tutorial, we will limit ourselves to two variables. Note that the intercept is represented by b sub 0, the first slope by b sub 1, the second slope by b sub 2, and so on. The owner of a carpet store believes that demand for her carpet is a function of both the period number and the number of new housing starts in the same period. The data is shown on the screen. Note that these periods are quarters, although that does not impact how you work the problem. Here we see the Excel Data Analysis Toolpack results. The correlation coefficient, or multiple R in Excel, is 0.9913. The intercept is 25,140.00. The slope for the period number is 3,399.51. The slope for housing starts is 75.43. You now see why I recommended that you include the labels with the data back in the Data Analysis Toolpack tutorial. Without those labels, it would not be plain which slope applied to which variable. As we saw from the printout, the slope, or b sub 0, is 25,140. The period slope, or b sub 1, is 3,399.51, and the housing start slope, or b2, is 75.43. Now that we have the parameters to use with the data, we are ready to perform the calculations. F1 equals 25,140 plus 3,399.51 times 1 plus 75.43 times 178 equals 41,966. F2 equals 25,140 plus 3,399.51 times 2 plus 75.43 times 554 equals 73,727. F3 equals 25,140 plus 3,399.51 times 3 plus 75.43 times 1,401 equals 141,000.16. F4 equals 25,140 plus 3,399.51 times 4 plus 75.43 times 128 equals 48,393. F5 equals 25,140 plus 3,399.51 times 5 plus 75.43 times 180 equals 55,715. F6 equals 25,140 plus 3,399.51 times 6 plus 75.43 times 565 equals 88,155. F7 equals 25,140 plus 3,399.51 times 7 plus 75.43 times 1,443 equals 157,782. F8 equals 25,140 plus 3,399.51 times 8 plus 75.43 times 129 equals 62,067. F9 equals 25,140 plus 3,399.51 times 9 plus 75.43 times 182 equals 69,464. F10 equals 25,140 plus 3,399.51 times 10 plus 75.43 times 576 equals 102,583. F11 equals 25,140 plus 3,399.51 times 11 plus 75.43 times 1,486 equals 174,624. F12 equals 25,140 plus 3,399.51 times 12 plus 75.43 times 130 equals 75,740. When we did moving averages and exponential smoothing, we prepared a forecast going one period into the future. With simple regression, we are able to forecast as many periods into the future as we wish. Why did we stop at period 12 in this example? This example illustrates the problem of basing a forecast on a variable other than the period number. In this example, the forecast in any period is based on both the period number and the number of housing starts for that period. Before we can forecast carpet sales for period 13, we would first have to prepare a forecast for the number of housing starts in period 13. Once we had the forecast for the number of housing starts in period 13, or any period for that matter, we could plug that into our formula and prepare a carpet sales forecast for that period. We will leave off the example at this point. The owner of a carpet store in another part of the country heard about the success the first store had with forecasting based in part on the number of new housing starts and decided to try it for himself. The data is shown on the screen. Develop a multiple regression forecast using new housing starts and period numbers as the independent variables. Since you've seen an example already, let me suggest that you pause the video and try to work this problem on your own. Once you're done, you can use the video to check your work and spot any mistakes you might have made. The screen shows the printout of the Excel Data Analysis Tool Pack for this data. The correlation coefficient is 0.9919, so this model is a slightly better fit than the last example. The intercept is 22,064.8. The slope for the period variable is 1,328.3. Finally, the slope for the new housing start variable is 47.71. We are now ready to prepare the forecast. As we saw from the printout, the intercept, or B sub 0, is 22,064.8. The period slope, or B sub 1, is 1,328.3, and the housing starts slope, or B2, is 47.71. Now that we have the parameters to use with the data, we are ready to perform the calculations. F1 equals 22,064.8 plus 1,328.3 times 1 plus 47.71 times 137 equals 29,929. F2 equals 22,064.8 plus 1,328.3 times 2 plus 47.71 times 558 equals 51,344. F3 equals 22,064.8 plus 1,328.3 times 3 plus 47.71 times 1,226 equals 84,542. F4 equals 22,064.8 plus 1,328.3 times 4 plus 47.71 times 0 equals 27,378. F5 equals 22,064.8 plus 1,328.3 times 5 plus 47.71 times 138 equals 35,290. F6 equals 22,064.8 plus 1,328.3 times 6 plus 47.71 times 569 equals 57,182. F7 equals 22,064.8 plus 1,328.3 times 7 plus 47.71 times 1,207 equals 88,949. F8 equals 22,064.8 plus 1,328.3 times 8 plus 47.71 times 0 equals 32,691. F9 equals 22,064.8 plus 1,328.3 times 9 plus 47.71 times 139 equals 40,651. F10 equals 22,064.8 plus 1,328.3 times 10 plus 47.71 times 580 equals 63,020. F11 equals 22,064.8 plus 1,328.3 times 11 plus 47.71 times 1,187 equals 93,308. F12 equals 22,064.8 plus 1,328.3 times 12 plus 47.71 times 0 equals 38,004. If you found that this video helped you with your operations management problem, please consider liking the video and even subscribing to the channel.